Parkinson's disease drugs. So here we will talk about the various drugs that are used in Parkinson's disease. We'll discuss the mechanism, mainly how different drugs act with different mechanism and helps in this disease. So we know that Parkinsonism is a disease that hits at old age, and this is very debilitating disease and causes great disability both economically as well as socially. That is, it not only affects the individual but it also affects the people who are related to that person, because the person with time depends on their spouse, okay, or their children because of this disease. The main symptoms of this disease is rigidity, tremors, and hypokinesia. You can call this person as a slow man, okay, because he becomes so slow that to carry out any activity it takes them a long time, okay. And why it occurs? Because there is a decreased level of dopamine in the brain, okay, and it occurs because of the degenerative changes that occurs in the basal ganglia. So with time the neurons get destroyed, right? And we know that once the neurons are destroyed, they are degenerated, there is no way we can create new neurons. So there is no definite treatment for this disease, but we can try to increase the dopamine through various mechanisms, which I will explain you with the help of this diagram. So what we need is, we need to increase the dopamine. Okay, so let's discuss the normal pathway. Okay, there is a L-dopa. Okay, with the help of dopa decarboxylase, it gets converted into dopamine, gets stored in the vesicles, and whenever stimulus arises, this dopamine, which is stored in the vesicle, will be released in the synaptic junction and will be acted on the dopamine receptors, which will be located in the postsynaptic membrane, and this will carry out the functions. Now when we don't have this dopamine, all the trouble arises. So let's try to increase the dopamine with the help of various drugs. So first drug we have invented is this carbidopa plus levodopa. When we give carbidopa levodopa orally, they will be get absorbed, okay, in the blood, and out of this carbidopa and levodopa, only L-dopa will be able to cross this blood-brain barrier. So this part is the circulation and this part is the brain, right? And this carbidopa, what it will do is, it will cause inhibition of this enzyme, that is dopa decarboxylase, in the circulation, so that most of the drug reaches the brain and won't be converted into dopamine in the circulation. Because if this L-dopa gets converted into dopamine in circulation, then there will be very much less amount of the dopamine which is left, L-dopa, which is left to reach the brain, okay. That means the dopamine that is formed in the circulation will be all wasted. So this is of no use, because this cannot cross the blood brain barrier, because this is protein, right? This cannot cross the blood brain barrier. So we need to preserve most of this L-dopa, so that it can cross the blood brain barrier and reach the neurons in the brain. So we have invented this drug, that is carbidopa. So it will inhibit this dopa decarboxylase in the circulation, while this carbidopa won't be able to cross this blood brain barrier, so it will not reach here. So now only L-dopa will reach and will be converted by dopa decarboxylase into dopamine, and it will carry out its function. Next we can do is, now the dopamine that is formed, okay, will be destroyed, okay, with the help of this enzyme, that is COMT enzyme and MAO-B enzyme. So we have invented a drug that will inhibit these enzymes and in turn will prevent the dopamine metabolism. So the COMT is inhibited by tolcapone, and MAO-B is inhibited by selegiline and resagiline drug. So in this way we will have increased amount of dopamine in the brain. Then when dopamine is released in the synapses, there is a uptake receptor also. You can see that this is the uptake receptor. Okay, with this the dopamine will be absorbed back and will be get destroyed in the neurons. But we have the drug that is amantadine, which will inhibit this uptake. So there will be increased amount of dopamine here in the synaptic junction. Then we can also try to directly stimulate this dopamine receptor. Okay, so this is the dopamine receptor. So we can directly stimulate that receptor. So we have drugs that directly stimulate the dopamine receptors, that is dopamine agonist drug, because they behave as a dopamine. Bromocriptine, which is ergot, and pramiprazole and ropinirole, which are non-ergot. Right? So in this way, we can increase the dopamine. So our aim is to increase the dopamine. We can do it by giving dopamine from outside. Okay, that is, I have already told you that L-dopa. We can do it by, so one thing is by giving dopamine, right, in the form of L-dopa. Then we can inhibit its destruction with the help of, so inhibit its destruction, decrease destruction. Then third step, we can decrease the uptake with the help of amantadine, or we can directly stimulate the receptor, directly stimulation of dopamine receptors. So our problem is decreased dopamine. So we need to find the dopamine from outside, or we need to prevent its destruction, or we need to directly have some drug that can act on this dopamine. And so dopamine will be increased and our problem is resolved. The patient will be relieved of the symptoms. But you know that this all is not that much promising, because once the neurons is degenerated, they cannot be regenerated, right? So with time, what will happen is more and more neurons will get destroyed. Okay, and as a result, we will have so very less amount of neurons that it won't compensate. Okay, whatever however hard we try, because when we are giving a drug, there is some dose, okay, above which we cannot give. So we keep on trying to increase the dose, but at one point we cannot increase the dose. And on other hand, like if we have reached the maximum dosage capacity, and we have also reached the stage where we have very less neurons, so the stage will arise where we cannot compensate. Okay, so compensation, there will be no compensation, and patient has to survive, okay, with suffering. So yeah, there is no definite cure, because we cannot regenerate neurons, right? So that's a problem with all this um brain diseases. Okay, like if we take multiple sclerosis, we don't have the cure, okay, permanent cure. If we take this Parkinson's disease, we don't have the permanent cure. So there are some diseases we don't have the cure because there is no regeneration of the cells. Okay, so we can just help them to resolve their symptoms, but there are no promising results yet now. But this drug has been found that if we inhibit the metabolism, okay, of dopamine, then reactive oxygen species, that is free radicals, okay, the generation of the free radicals will be decreased, and this will be helpful for preserving neurons. So these drugs are very much effective in preserving the neurons, but it will just slow down the process. It won't be able to stop the process. So again, we don't have the cure, but at least we can help the patient, okay, to have a better life. And so yeah, that's all for this video. Hope you like this video. Please don't forget to like, subscribe, and share. And thanks for watching.